Hello. Good, Hey, good morning. Good morning, good evening, good afternoon, everyone. Welcome to today's Reactor live stream. My name is Erica, and I am the Microsoft Reactors Stockholm Program Manager. I'm very happy that you are joining us today for the very first episode of the Game of Learners Clinics, which is a 5-week skilling initiative to help you to learn and gain technical skills on how to work with data in the cloud. Before we start, I would just like to say a quick word about Microsoft Code of Conduct. Please be aware of each other and be welcoming and respectful. We are all here to learn, so please be understanding of differences. Today, I'm very happy to bring here a dear colleague, Paul DeCarlo, and Josh as well. Hi guys, hello, how are you?
Hey, we're doing just fine, Erica. Ready to get started with the Game of Learners Data Clinics, and super happy to be joining the Reactor for this series.
Yeah, great. It's great to have you here. And then Paul, you are a principal cloud developer advocate based in Houston. And Josh, you are tuning in from Kenya, if I'm right?
Yes.
Yeah. Super international. In Stockholm, we have US, we have Africa. This is a great start. I'm sure our audience is tuning in from all over the world as well. So yeah, I'm just gonna put myself into the background, and I hand the word over to you, Josh, or Paul. Sorry.
Excellent. Yeah, thank you, Erica, for getting us started. So yeah, welcome to this live stream event, this Learn Live session that we'll be presenting today. This is the Game of Learners Clinics for Data Fundamentals of Azure SQL session. And again, my name's Paul DiCarlo, as Erica mentioned, Principal Cloud Advocate at Microsoft. And I'm joined here by Josh Indamenge, who's based out of Nairobi, Kenya. Say hello, because Josh is going to be working in the background, answering your questions, running the live chat, moderating things, and pulling your questions into the actual presentation. One thing just to note before we get started, you'll notice this URL, the aka.ms/Azure SQL Data Fundamentals. For folks that are joining us today, you can follow along with the Learn Live content. That will actually link you to the following session or collection of modules that we'll be covering today. So definitely, if you are going to be following along, you want to head to aka.ms/Azure SQL Data Fundamentals, and that will get you into the correct path. So we should see that link live on the screen below. Awesome. Josh, do you have any words before we get started? I know this is a kickoff session. This is an exciting series. Something you want to tell our viewers out there before we get started?
Thanks, Paul. So yeah, I'm excited that we are kicking off our first session of this series. So Paul will be sharing all the relevant links for this series as we proceed. And I'll ensure I have those on chat as well. And actually afterwards, I'll head over to Tech Community for like 15 minutes, so that if you have any questions that wasn't answered, you can always post it there, and I should be able to respond from there. Thank you.
That's awesome. So yeah, you've heard it there. Josh is going to be your expert on all things related to data, helping you in that chat and also helping you in the forums, which we'll talk about here in just a sec. So Game of Learners Clinics for Data. This is the full 5-week series that we're going to be running. If you are interested in joining us for our future upcoming sessions, you can sign up and register for all of those by visiting aka.ms/GOL Data Clinic. That will take you to the Microsoft Reactor event page for this series that will allow you to sign up for each individual session. And as you can see, there's a lot to look forward to. We've got information about Azure SQL. We're going to be doing some learnings on Cosmos DB, teaching you the ins and outs about Azure Storage, looking at real-time analytics. And Josh is actually going to kick us off at the very end with the finale on Azure Synapse Analytics. So teaching us what you can do with your data. That's going to be a cool one, Josh. I can't wait till we get to that.
Yeah, sure.
And so with that said, yeah, definitely make sure you're signing up for those sessions, because if you attend all of those sessions, well, at your leisure, you don't necessarily need to be there live, but if you go through the content that's presented there, and you're one of the first 200 people to register at the link that's on the screen right now and complete the content in the Microsoft Learn modules that we'll be presenting on, you'll be able to sit for the DP900 Microsoft Azure Data Fundamentals exam for free. So that is open to the first 200 individuals who go to the aka.ms/dataclinic/register. Register there. That will link you to a cloud skills challenge that contains a collection of online content and modules that if you complete, you'll be able to get a free voucher to sit for the DP900 Microsoft Azure Data Fundamentals exam. And something else that Josh hinted at as well was that for learners who are on their path to certification, you can always head to aka.ms/dataclinics/forum. This will bring you to a tech community page where you'll have people asking questions about exactly the content presented in the GoL data clinics. So if you need additional understanding, maybe you're having trouble completing a certain module, at any point in the day, you can go there and receive live or sometimes delayed responses, but help from the community really at large. So that's really awesome. So do stay tuned because Josh is going to be present for about 15 minutes after this live stream, taking in questions that appear on the Data Clinics forum. So with that said, before we go ahead and get started, I just want to make sure everybody understands this is a live and interactive session, meaning that you can ask questions. We'll surface them and get those answered live. And also to have folks chat amongst each other, you know, whether you're learning something new, whether you have information that maybe you want to share with other individuals here who are learning alongside. And if I was going to say the first thing to get started, again, I think this is a wide international audience just from us, the hosts, Sweden, we've got US, we've got Africa represented here. So I'm curious, where's the audience from? If y'all want to say hi and where you're from in that chat, we can start to get a bigger picture on who's joining us. So again, I want to say good morning, good afternoon, good evening, wherever you happen to be. We'd love to know where you're tuning in from. And with that said, I think we're now ready to start with the Learn Live, Explore Fundamental Relational Data Concepts. This particular module you can get to by, again, heading to that aka.ms/Azure SQL Data Fundamentals link. That's going to bring you to the Microsoft Learning path that contains the two modules that we're going to cover today. So you're definitely going to want to head to this link in order to follow along with the content that we're just about to dive into. So that's, again, aka.ms/Azure SQL Data Fundamentals. And what we're going to learn about in this session is a few things. Some of you may already be familiar with this. Some might want a refresher. We are literally starting from zero here in the GoL Data Clinics because we want to be open so that anybody can start to begin learning and applying some of these concepts and hopefully extend those into cloud deployments. So we'll begin by identifying characteristics of relational data, define the concept of normalization, identify different types of SQL statements, and identify common relational database objects. So let's go ahead and get started. If you do head to that link, aka.ms/Azure SQL Data Fundamentals, that's going to bring you to the following learning path. We're going to jump into the first module, this Explore Fundamental Relational Data Concepts. So we're going to go ahead and get that opened up. And again, you'll see the learning objectives that we had just mentioned. That is what we're going to discover here. And as I said, we are literally starting from nothing. So the prerequisites for this session are absolutely nothing. You are ready to just dive in no matter where you happen to be in your learning journey. So let's go ahead and get started with the introduction module and talk about where SQL came from, where relational databases came from. In the early days of computing systems, as you might assume, applications needed to store data. And one of the ways that they would accomplish this was utilizing unique data structures, or basically sometimes like in-memory sort of ways of representing data. This could be, you know, the kinds of things you would hear about in computer science that were not necessarily scalable, but stored your data. So it kind of like solved the problem, but didn't necessarily do it in an optimal way. And that's where the relational database model comes in. Is this is a concept that leverages something called tables, which are an intuitive, efficient, and flexible way of not only understanding, but also being able to access in a programmatic fashion and an optimized fashion structured information. And as you're going to learn, if you're not familiar with the relational database model, this is a simple but powerful model that's been used in numerous different organizations, numerous large-scale applications, and is often the backbone of inventory trackers, commerce, transactional systems, and mission-critical customer information storage in general for companies that could be doing any line of business. So in this module, we're going to learn how these things work, what comprises them, and some of the key concepts to introduce you to SQL, or SQL as it's often referred to. So we'll begin by understanding relational data. And the first thing we want to look at here is that in a relational database, we store our collections of data as entities in a structure known as a table. And these entities could be anything that you want to talk about. For example, an object or an event. So like in a retail system, which is what we're going to be looking at today, this would be things like customers, products, orders, or maybe line items that make up an order. And each table contains rows, and each row will represent a single instance of an entity. So in the retail scenario, each row in the customer table is going to contain information or data for a single customer. And each row that you'll see that's in, say, a line item table would include the items that were ordered in a particular purchase transaction. So you look at this structure, and this doesn't look probably too unfamiliar. It looks like, what you would see in Excel or some other familiar data tool. It's a row, it's got data in it, but there's certain things that we want to pay attention to, and we're going to go into more details as we talk about this, which is this concept of the ID, which we'll later refer to as a primary key, or sometimes can be used as something called a foreign key for referencing data across tables. And also notice that in some of these rows, you'll notice that there's missing data. So for example, in this customer table, the middle name doesn't necessarily need to have a value. And there's ways that we can tell database systems whether they need to expect a value for something or whether it might be okay to leave something out. For example, a customer who doesn't have a middle name. One other thing to pay attention to is the data type, so how data is stored. So first name, middle name, last name, these are of course going to be text-based or variable character length data. ID is going to be some sort of a whole number, and price is going to be some sort of decimal or floating point value, whereas order date is a date time. Now, why is that important? Because of course the different properties of different data types allows you to perform different capabilities. For example, how you might sort the data. Maybe you want to do a composition or add prices together in order to achieve a total. All of those things become important in the relational database model. So we're now going to talk about this concept of normalization, which I sort of hinted at a little bit earlier. This is a term that's used by database professionals for a schema design process that minimizes data duplication. That's the key thing I think to focus on here, is minimizes data duplication and enforces data integrity. So while there's many complex rules that can define the process of refactoring data into what we call levels or forms, a simple practical way of accomplishing this is by separating each entity into its own table, separate each discrete attribute into its own column. So you can think of an entity would be, in this case, customer, and then an attribute would be first name, last name. Uniquely identify each row using a primary key. So in this case, the ID field is the primary key, and use a foreign key to link related entities. So foreign key might use something like, in my light item, I'm referring to a product, and that product is being referred to by its primary key, which we call this a foreign key in this table, but it is the primary key of the table that it is referring to. Hopefully that makes sense, because if you put all this together, this can allow us to compose data from different tables into something like a total all-up report, for example, something like sales data that contains order number, order date, customer, product, and quantity. But you'll notice how that data is coming together in that singular view there may be from disparate tables. And those disparate tables are able to be brought together through that process of normalization. So if we look at this and look at the concept where each entity is represented in our data as a specific table, each discrete attribute has its own entities and its own columns, we start to not have to duplicate data if we simply refer to things by their primary key. So in the line item table, I don't need to store the name of the hammer, the price of the hammer. I can simply use its ID and I can reference all of that information directly. And what we call this, whenever you're looking at those keys and then basically referring to their actual values in the other table, is called a decomposition of attributes. And so this allows us to make sure that the tables that we're referencing are always what we're looking for. And instances of each entity, as you've seen, are always identified by that primary key. When one entity or one table references another, the primary key is stored as a foreign key, as we've mentioned here. So this allows us, again, what's the benefit here? I don't have to duplicate my data across all of my tables. We can use this concept of the foreign key in our table to look it up in a related table, and from that be able to compose all of the information contained within together. In some cases, a primary or foreign key can be defined as a composite key. And this is actually pretty interesting. This could be based on combining or concatenating or putting together a combination of multiple columns. For example, above, the line item table actually uses a primary key that is a combination of order number and item number in order to identify the actual line item. So you can see here, we can take that order number and combine it with the item number, and that would give us a 10001 or a composite key that's using two different keys that are stored in the table to create yet a new one. Again, this is something, it depends on how your database is structured, but hopefully these concepts are making sense, because these are what ultimately makes up your larger scale data systems when they're using the relational data model. So you've heard this term thrown out. What is SQL? Or SQL, as it's often mentioned as. So this stands for Structured Query Language, and is how we communicate with relational databases. It is a standard language for database management systems. And SQL is used across the board, not just in products like Microsoft SQL Server, but also open source products like MySQL, PostgreSQL, MariaDB, and Oracle. So it's interesting that these concepts that you're going to learn about shortly, if you're not already familiar, for example, things like select, insert, update, delete, create, and drop, are going to be available in all of the aforementioned database systems. And although these SQL statements are part of a standard that was developed by the American National Standards Institute, some database systems can also have extensions to this, or proprietary extensions that can handle additional features. These would cover functionality that's not provided in the ANSI or ISO defined SQL standard. And these include things that covers things like security management and programmability. For example, Microsoft SQL Server and Azure Database Services are based on something called Transact SQL, which is a dialect of SQL that allows for proprietary extensions to write something called stored procedures and triggers, which we'll talk about shortly, and also being able to manage user accounts. Postgres and MySQL also have their own versions of these. So if you're looking across the board on what we've talked about, Transact SQL or T-SQL is the version of SQL used by Microsoft in Azure SQL Services. PG-SQL is the dialect used by PostgreSQL, and PL-SQL is what is used by Oracle, which stands for Procedural Language SQL. One thing to note as we go forward in the remainder of this content, unless otherwise indicated, all examples are based purely on the Transact or T-SQL dialect. While this might be familiar, similar, or compatible in other forms of SQL, we just want to be very, very clear that what we're showing as we continue forward is all examples that are specific to Transact SQL. So let's start learning a little bit about SQL statement types, and we're going to do a quick crash course on these. where the quickest way to understand these is, I think, by breaking them down into their different types. So we have DDLs, or data definition language, DCL, or data control language, and DML, which is data manipulation language. And you use these DDL statements to create, modify, and remove tables and other objects in a database. So these are very powerful commands, these data definition languages. These can allow you to create a new table, alter the structure of a table by changing the columns, how they're represented. One, if you're not familiar, that you definitely want to focus on and commit to memory right now is drop. Drop will actually remove a database. If you drop a table, all data in the entire table will go away. And also rename, which sounds like it is. It allows you to rename objects. Now, again, I want to reiterate that drop statement is so powerful that it will cause you to lose all rows in the table. So unless you have a backup, you will not get it back after leveraging a drop statement in a SQL query. So just make sure that you're aware of that. In the following example below, we're going to show utilizing a create. We're going to use that creates query to actually build a table from nothing. And you'll see here when we run this SQL query, we're doing a few things here that go back to things we've talked about already in the presentation. Number one, the first thing we're setting up is this ID of type integer, which we're specifying as a primary key. Then we're allowing a name field for this product table of variable length that can be not null. So starts off with a character length of 20, but could be variable, meaning that it could be less than or exceed. That is not null, meaning this name field has to be supplied. Otherwise, if you're inserting a row, it won't accept that because it has to be not null. And a price that is nullable. So you'll see the way that we're specifying how we want our table to operate or appear, what's going to make up that structure or schema is defined here in this specific query. Our DCL statements, or data control logic, is going to allow us to manage access by granting, denying, or revoking permissions. This would usually enact on users who have some sort of a credential within the database. So the three different types of DCL statements are grant, which will allow you to perform an action, deny, which will not allow you to perform an action, and revoke, which if you've already granted something and want to take it away, you would use the revoke. So here's an example of one of these DCL statements in action where we're granting the ability to select, insert, and update, which we'll talk about in just a second, on the product table to a user named user1. So user1 can select, insert, and update, but they're not necessarily able to drop a table because they haven't been granted that permission. And finally, in our DML, or data manipulation, we're going to look at statements that will allow you to manipulate rows in your tables. These ultimately allow you to do things like retrieve and query data, insert new rows, or modify existing rows, or even delete them if you don't need them anymore. So you'll see here the select, which allows you to read, insert, which inserts rows, update, which modifies existing rows, and delete, which deletes. And the basic forms of the insert statement will always insert one row at a time. And by default, select, update, and deletes are applied to every row in a table, unless you use something like a where clause, which we'll talk about in a moment, to filter out based on specific criteria. Now, again, SQL doesn't prompt you with warnings when you're about to do something serious. So remember, deletes can be applied to every row in a table, and you might not want to do that. So be careful when leveraging these delete statements inside of a query, because if you're not specifying with a where clause, it's possible you could lose or modify data that you didn't intend to. So the following is an example of a SQL statement that is retrieving all columns indicated by the star from our customer table based on the criteria of where the city is equal to Seattle. Now, if you didn't want all columns and you wanted a subset, you can specify those. You can say select first name, last name, address, city, again, from my customer table where city equals Seattle. And finally, if we want to retrieve those and order them, perhaps alphabetically, we could say select first name, last name, address, city from customer table where the city equals to Seattle and order that by the last name. You can also, not to be super confusing, but this is the last more advanced concept we're going to leave you with, is retrieve data from multiple tables and see that in a singular result using what's called a join. And joins work on this concept of matching your primary keys to a foreign key in another table. So again, that concept of normalization that we were looking at earlier becomes very relevant here. And to be a little more confusing or make this even easier to read, arguably, we're going to introduce the concept of aliases. So in this case, we're selecting O.order number and O.order date. What is O? Well, O is from order, and we use this syntax as, which specifies an alias where order can now be referred to as O. So when we say O.order number, that means from the order table, the order number column that is within the order table. Join the customer table, which we're also going to refer to now by a alias C. So we're going to pull the order number and order date columns from the order table and the address and city columns from the customer table on where order.customer equals customer.id. So in this case, on the foreign key of customer that happens to be present in the order table where it matches with the primary key in the customer table. So hopefully that made sense. And if not, if you are confused about any of these concepts, again, this would be a great time to ask questions or, again, think about where you could bring these things into our forum for discussing these later on throughout the clinic. The next example will show how to modify an existing row. So if we want to update a value that's already been entered, we can do update customer table set address equal to the following value where ID equals 1. And again, if you omit this where clause, it will set the address for every row in the table. So you can see how it's very easy to quickly modify way too much data if you're not paying attention. So similarly, when we're doing a delete statement, this would look similar. Delete from product where ID equals 162. If we did not have this where clause, it would just delete every row from the table, and you don't want that. And finally, the insert statement, which is out of all of these, the one that takes a slightly different form than the others. When we want to add a new row into a table, we specify this with the following query: insert into table name, column name that I'm interested in, then the values that we'd like to apply respectively to that column. So this statement would add a new product entry with an ID of 99, a name of drill, and a price of $4.99. It's interesting to note here that while we're showing entering one new row with our values here, it is possible in some dialects to actually be able to specify multiple value clauses to generate numerous rows, more than one at a time. So there's our crash course on SQL query language. Hopefully folks are learning something new here, and folks who are familiar with these concepts, maybe there's something that you didn't notice or you were able to refresh on, because we're about to start using this a lot more, especially as we go into our next module. So we're going to now look at what is a view and put together those concepts we just learned about. So a view is really nothing more than a referenceable virtual table that is based on the results of a select query. And this can be a complex select query or one that contains a join, as we saw earlier. So all we're doing now is that same select statement we saw previously, we're now adding in create view deliveries as, and basically having almost the same syntax that we saw previously. Now that we have this created view, we can reference that. So this new view named deliveries now becomes something that we can reference with queries. So we can now say things like select order number, order date, last name, address from deliveries, which was created as a view in the previous statement, and even enact filtering, for example, a where clause like where city equals Seattle. You can think about how this could be useful, because if you have a really good view that comprises data from multiple tables, There's different ways to interpret the data that you're storing and make use of it for certain business transactions or reasons. And next, we'll look at what is a stored procedure. This is a way to run essentially programmatic logic in a database. What it looks like to create one of these, you'll use the syntax create procedure, name that, and then have essentially a parameter name and the type that it takes. So if you've ever done any programming in any popular declarative languages, this probably looks familiar. It looks like creating a function. And more or less is essentially like that. And then we'll say as and what we actually want that programmatic logic to do. So in this case, we want it to update the product table and set the name equal to the value of the new name parameter, where the ID is equal to the product ID that's passed along. So now that we have that defined, we can actually run a command exec rename product 201 spanner, which will find the product with the ID 201 and actually set its name to spanner. And the last concept we'll look at is an index. And going over this super quick because these actually get complex depending on the database and the data type, works basically on the concept of like if you're looking in a book and you flip to the back of it and it'll have an index. It'll tell you when certain key things were mentioned, where you can reference like, if you've ever read a manual or try to fix a car, like, where's the headlights, right? And you flip to the back and it'll tell you exactly what page to go to find that information. Well, indexes work the same way in databases, where by simply specifying that we want an index, something called a query optimizer will go through, scan all data in that table, and basically partition it in such a way that it can find the data a lot faster than it could if it didn't have to go through and read by row by row by row by row. So what this looks like in action, we would use a query that's something like create index IDX underscore product name on the product table. And because the product table is stored as character data, it would look at the size of that table, and the query optimizer could begin splitting that into buckets, perhaps A through L or M through Z. Maybe as that table grows and there's more entries, maybe have one for every letter of the alphabet or some other optimized structure. But just for sake of demonstration, showing you that it can split these out in such a way that now it no longer has to scan the entire database to find an entity. So if we were looking for, say, the hammer, it could find that in the A through L section, and screwdriver similarly would be in the M through Z, allowing us to divide, not looking at half of the data that would essentially comprise our table. And that's the ultimate optimizer that you get here. It's important to note that indexes aren't free. They do consume storage, and each time the table changes through inserts, updates, or deletes, that index needs to be remaintained, which can slow down certain operations. But if you strike a balance between having indexes, you can speed up your queries in ways that will be significant. Of course, if you have small tables with not a little bit of data, perhaps it is arbitrary to scan through every row. But as that data grows large, and we're talking cloud scale, those indexes are certainly going to help save the day in making your life more optimized. So we're now ready for the knowledge check, as we are at the end of the first module for today's session. We'll go through these relatively quick. So which of the following is a characteristic of a relational database? All columns must be of the same data type. Well, we know that's not true because we saw examples earlier that had date fields next to integer fields. Similarly, we had integer fields and decimal fields next to character fields, so that's not true. A row in a table represents a single instance of an entity. That definitely sounds like a characteristic of a relational database, as you've seen in our examples. Or rows in the same table can contain different columns. All the examples we've seen, each row had the same column, so I don't think that's it. Which SQL statement is used to query and return data? Is definitely not query, because I'm not sure that we had a statement called query. Read is a permission. Select is definitely, that is actually, we saw some examples of that. So if we want to return data, we would use a select. And what is an index? A structure that enables queries to locate rows in a table quickly. That That sounds like it. A virtual table based on the results of a query, that would be a view. Or a predefined SQL statement that modifies data. That sounds like a stored procedure. So let's go with answer A. And we'll go ahead and check our answers. And hopefully you were using the same line of thinking here and going through this. But you've now got an explanation. If you thought otherwise, what's nice about Learn is it'll tell you why one answer. If you thought it was something, it'll kind of give you some understanding on why that shouldn't be the case. This is it. We've now completed our first module. We've learned how to identify characteristics of relational data. We've defined normalization. We learned about different SQL statements, and we identified common objects. So we're now ready to pursue our next steps. So the first thing I'm thinking we can do here is take a quick break to talk about the Azure Data Fundamentals certification. So for folks out there who thought this module was interesting, you're thinking that you want to dive in and learn more, there is much more to learn, and there's a lot more content out there. So you can head to aka.ms/Azure SQL Data Fundamentals Cert to get started on pursuing a Microsoft certification in Azure Data Fundamentals if you're interested in learning more. And similarly, I want to remind folks that as part of this Game of Learners Data Clinic, the first 200 individuals who head to this link, aka.ms/dataclinic/register, and register there and complete the Learn content or modules, which we just completed one of them. If you complete those within and you're one of the first 200 individuals, you'll be able to sit for this Azure Data Fundamentals exam for free. So again, that link on the screen, aka.ms/dataclinics/register. And of course, if you need help, definitely join the AKMS Data Clinics forum for answers to your questions as you proceed. So we're now ready to continue with our second module for today, which is exploring relational database services in Azure. We're again going to start from the same place that we were earlier, which is that aka.ms/Azure SQL Data Fundamentals URL. And we're going to jump into module 2 there, which is called Explore Relational Database Services in Azure. What I really like about this is how much this is going to build on the content we just learned. So if things seemed familiar, maybe you've worked with relational databases before, but you haven't worked with them in the cloud, now we're going to take that information we just learned and extend that into a whole new area of cloud scale relational databases. So hopefully that's going to get you excited. And the great thing is the prerequisites for this are a fundamental understanding of relational data concepts. So we've got that. We just did all of that together. We're ready to go. So we will learn today about options for Azure SQL services, options for open source databases that are of a relational type in Azure, and also provision our first database in Azure. So we can proceed. If you are on the section where we just completed, you can click the link to review your learning path history, and that will bring you back. And we should be able to jump into exploring relational database services in Azure. So go ahead and open this one up. And again, as we mentioned, we'll be learning about SQL services, open source databases in Azure, and even provision a database in Azure. So in getting started, Microsoft Azure, as you're probably aware, as a cloud service, supports many abilities to deploy different types of database systems. And in the context of relational database management systems, it supports out-the-box support for SQL Server, PostgreSQL, and MySQL in the cloud. And what you essentially get from the benefit of deploying in the cloud is freeing up time that you wouldn't necessarily need to set up and manage a resource, enterprise-grade performance and high availability, the ability to scale up and scale down resources so that they can grow to handle your demand and also shrink when it's not there, so it's not costing you extra money for services that you're not using. Having built-in security features, threat detection, and performance, and all these features really just come because you're deploying into the cloud, where we make a home for these services. So we're going to look at Azure SQL services and capabilities, because in Azure, there's a collection of different flavors of Azure SQL, if you will. And so the collective term for a family of Microsoft SQL services based in Azure is Azure SQL. And these include the ability to run SQL Server on a VM. So if you've ever used a virtual machine, this would be your IaaS or infrastructure as a service mechanism, allowing you to deploy an instance of essentially a computer in the cloud that you would install SQL Server on. Hopefully that makes a lot of sense in how that's accomplished, and is a great way to lift and shift if you're migrating an on-premise SQL solution to the cloud. However, this comes at a cost, because since it's infrastructure as a service, you have to maintain that computer. You don't have to put the power supply in it, you don't have to put the hard drives in it, but you do have to ensure the OS updates, any sort of security patches and things like that. You would essentially be on the hook for managing those. Whereas if you go with something like a managed instance, which is a platform as a service offering, you'll get almost near 100% compatibility with that same previous aforementioned mechanism for deploying SQL. However, this is also going to include automated update management, automated backups, automated maintenance tasks. So the administrative cost is reduced when we use a managed instance. And taking that even smaller, you can use an Azure SQL database, which is a database service that just includes the deployment of a single database, where all of these management and database level capabilities are taken care of for you. And finally, for completeness, there is an offering called Azure SQL Edge, which is a SQL engine that's optimized for Internet of Things or small form factor single board computer type of scenarios for working with streaming time series data. So we include that in this list for completeness, but we're primarily going to be focusing on these three options as we continue with different sessions in the Game of Learners tracks. So again, we have a full table here within the module that covers this again. And just to reiterate that, the IaaS-based solution is going to require that you install your updates. At the same time, you're going to get SQL, and it's going to look exactly like SQL installed in an on-premise environment. It's just like if you installed it on your laptop or your desktop. It is that, but in a VM in the cloud. But also, again, comes with all of the maintenance aspects. Whereas with the managed instance, you'll get an ability to use SQL Server. However, you're also going to get automated updates, backup, and recovery, and the ability to do things like instance pools that can allow you to share across multiple different deployment areas whenever your application needs, say, additional data, or perhaps is in less demand and needs to scale back. Ideally, if you're also looking at just building a net new application in the cloud, you just simply need a SQL database. There is an Azure SQL database option that will just give you a database. This is a bit smaller than what you would expect to get from a managed instance, as a managed instance can support multiple databases, whereas the Azure SQL database offering is a single database offering. Again, though, this can allow you to scale. Even though it is a single database, it can be deployed into multiple, what we call logical servers, that can allow you to scale up or down to demand. All of these solutions are great for migration. The first two are probably more likely what we see for larger enterprise scale level migrations. The final one is generally used when creating a net new application that is born in the cloud. So there's no rules against that, but just saying, like, these are kind of the common ways that these are utilized in the field. So for the business benefits that are provided here, we're just in the instance of time, we're not going to cover all of those, but just understand that each of these different offerings, for the aforementioned different reasons or different characteristics of those deployments, there are different benefits that come with that. And we go into a lot more detail here, but just don't have the necessary time to cover those in our live stream today. So I would suggest, folks, as a homework assignment, we can still go forth with completing this module, but if you're wanting to really truly learn how these things work underneath the hood, definitely come back, return here, and you'll want to go through this content on your own. So now let's look at Azure services for open source databases. These include things like popular relational database systems such as MySQL, MariaDB, and PostgreSQL. And the primary reason for these services is that if we can have support for popular open source databases in the Azure cloud, it makes it that much easier for customers or users to get started using familiar open source platforms without needing to make any significant changes to their applications. And so what exactly are these services that we're talking about? Well, MySQL is a very popular one that started as something that was often referred to as the LAMP stack, which means use of Linux as the operating system, Apache as the web server, MySQL as the database, and PHP as the web programming language. It was typically used in that formation, which makes up quite a bit of applications that are still online today. And this used to be the way essentially web pages were built, utilizing this LAMP stack as it's referred to. MariaDB is if you want to think about it, almost an iteration. It's a newer style database system that was created by, funny enough, the original developers of MySQL, but is completely rewritten and optimized for improved performance and offers compatibility with Oracle's database system as well. One of the notable features is support for temporal tables, meaning that in MariaDB, you can query data as it has appeared in some point in the past. It actually can keep that transactional log of the way the table looked over time instead of only having one particular view. And PostgreSQL is a hybrid relational object database. You can store data in relational tables, but also store custom data types with their own non-relational properties. And database systems using Postgres are extensible. They add code modules to the database, which can be run by queries, and can also do things like store and manipulate geometric data just by default. And this form of SQL, or this RDMS, or Relational Database Management System, uses its own language called PG-SQL, which is a variant of SQL, as we sort of talked about earlier with these different variants. What's really cool is that in Postgres, you can write and run stored procedures inside of your database. So you'll notice something that starts to repeat here as we go through these. So I'm gonna go through this section a little fast as well. Is that for all of our database offerings, whether that's MySQL, MariaDB, or PostgreSQL, the benefits that we offer tend to be common across all of those. So high availability features, ability to scale and handle high performance, the ability to have automatic backups, compliance, security features, all of the bells and whistles that you would expect from a cloud-based offering or service, we apply to our open source offerings as well as the Microsoft-based MS SQL or Azure SQL offerings. So we've made it this far. We're almost at the end of our live stream, and you're probably ready to really do something with all that we've learned. So there is an exercise at the end of here, and we only have time to go through one of these, which is to deploy a database. You'll notice there's options for deploying Postgres and MySQL. Definitely suggest, folks, that you go through those, time permitting. But for the purpose of our live stream, we're going to jump in real quick and launch the exercise for the Azure SQL database. Now, before you start, you'll need an Azure subscription, which could be either a free trial, or you could be using something like, you could be using one of the sandboxes, and Microsoft Learn can work here as well. Either of those are valid. So whatever you happen to have available as an Azure subscription, definitely you'll want to leverage that here. I'm going to go ahead and jump into my Azure subscription and have this side by side with the instructions here so you can watch and follow along. If you do need help accessing an Azure subscription, Josh can help you in the chat, give you links to either our free trial and or show you how to activate a sandbox in Microsoft Learn. Again, I want to mention there are definitely no cost options here. So in the Azure Portal, we're going to select from the hamburger menu here, create a resource. And in that resulting page, we're going to type in Azure SQL, run a search for Azure SQL offerings. Brings us into the marketplace, and you're going to see this should return a result here, Azure SQL. We'll go ahead and click on Create. And this gives me numerous options here. You'll see I've got SQL Database, the managed instance that we talked about in SQL Virtual Machine. For purposes of what we're going to do today, we're going to create a single database. And we'll be given the following prompt. If you've never used the cloud before, this is one of the things I just love, is that we can go from 0 to deployed in just a few minutes. In fact, I bet in about 5 minutes we'll have our database up and running. So what we're going to do here is choose the resource group that we want to put our stuff in. I'm going to choose one that I've created already called GoL Data Clinic. If you haven't, you can select Create New here and type in the new name, and it will create that for you. For our database names, we're going to go ahead and name it AdventureWorks. And we're going to go ahead and create a new server. So I'm going to select this Create New, and we'll give this a name. I'll call this GoL Data AW for AdventureWorks. I'll deploy this into the East US. And for our authentication method, I'm going to select this, give this a login name. I'll call this Cloud Admin, and a password that meets the requirements specified here. So I've gone ahead and typed that in, and we'll select OK. Now we'll select if we want to use an elastic pool. These are cost-effective solutions for managing multiple databases with a fixed budget. An elastic pool computes all of the resources used between a database and everything that's being shared between it. And databases within a pool only use the resources they need when they need them within limits. The price of a pool is based only on the amount of resources configured and is independent of the number of databases within. So just make sure you're aware of that. We're not going to turn that feature on. For the workload environment, if you're seeing that option, you'll want to go ahead and select development. And for compute storage, I'm going to leave this unchanged, but you'll notice if we do click into here, it'll give us some options for whether we want to be provisioned or serverless, etc. One interesting thing, if you do want to save cost here, you'll actually see here we get a estimate here that our current deployment's $53. You can actually change this configuration here. If you wanted, you could scale down to a lower class virtual machine. There's also an option here where we can come in and change to utilize DTUs instead of vCore as another possibility. So you'll see here this DTU-based purchasing model. If we do that and choose basic, my database now only costs $1.15 per month. In fact, I'll prove that it works because I'm going to go ahead and apply that and use this configuration going forward. For our backup and storage, it says choose locally redundant. So that means we'll just have a local copy of our database. And next, we'll move on to networking. For networking, we're going to choose a connectivity method of public endpoint. And we're going to allow Azure services to access the server and add the current IP, because by default, the database will be deployed with the firewall rules turned on so hard that it won't let anything communicate with it. We are going to enable this so that we can actually interact with our database. Also, it's technically optional when we move on to the security section. If you want, you can enable Defender for SQL. Start your free trial if you want to. Just understand that could incur costs later down the road. So I'm going to go ahead and select Not Now for that. And then very important, you want to move to the additional settings. And there's a section that says Use Existing Data Sample. And we're going to go ahead and choose OK. And once we've done that, we're now ready to move on to the Review Create. And we can click the Create button, which will begin that deployment. Now, this could take a few minutes to ultimately deploy this resource into my subscription. We'll give this just a few moments. And as that's going on, discuss what we're going to do next. And maybe for the instance of the time, I may jump into a database that I've already deployed using these same exact steps. So just in the instances of saving time. So what it's going to ask us to do here is, after we've deployed our database, to head into the query editor for that. So I'm going to go ahead and jump into my Game of Learners Data Clinics. And earlier today, I did create an AdventureWorks database containing that same sample data. And inside of here, if I go ahead and expand this, you'll see here there is a query editor. And I should be able to log into this with the credentials that were created during deployment. Use a certificate if asked, and log in as my admin user. Oops, looks like I may have mistyped that password. And now I've logged into my table. Now, if you haven't enabled your IP as we did during that security step previously, you may get an error message that is going to ask you, stating that the IP address isn't displayed. If you do get that message, you will want to go ahead and enable that. So what we're going to do is jump into our table here. So we'll move this over. We're going to jump into our database and run the query that it's mentioning here, this select star from sales LT product. And we know what that means because we just took a crash course on SQL. That's going to pull every column from the database. And that's exactly what it's done. Every column, name, product number, color, standard cost, etc. We're now going to proceed with the next example query, which is going to show us how to pull out specific columns. So if we run a modification of this query, select product ID, list price product category from sales LT.product, you'll notice now I only get a subset of that data returned. Only the columns that I was interested in. And next, we can do a full join by combining information from the product table and the category table using a join. So this is a more complex query to produce a result. Oh, yikes. Looks like I copied that incorrectly. Try that again. A syntax error. And you'll see we're now able to perform a joining of the product and category table to create a product category table. And with all that, you've now been able to put into action some of those queries that we looked at earlier. So again, if you want to look at doing this and trying this with some of the open source databases, definitely recommend heading back and trying the additional exercises available in our Learn module. So we're now ready to move on to our final knowledge check. And we'll go ahead and get started, demonstrate our understanding of the concepts learned today. Which deployment option offers the best compatibility when migrating an existing SQL Server solution? Is that an Azure SQL database with Elastic Pool, or Azure SQL Managed Instance? I think when migrating an on-premise solution, the managed instance is certainly going to be the answer here because it can handle multiple databases. Whereas for Azure SQL database, that tends to be better for net new applications that are born in the cloud. Which of the following is true about Azure SQL database? Most database maintenance tasks are automated. That seems true. You must purchase a SQL Server license, and it can only support one database. Well, I think that depends, right? It depends on how it's deployed. I would say most database maintenance tasks are automated. Sounds like the answer here. And which database service is the simplest option for migrating a LAMP application to Azure? It can't be Azure SQL Managed Instance because LAMP is Linux, Apache, MySQL, PHP. The only answer here that mentions MySQL is this one. So let's go ahead and check our answers. And you'll see these are correct hopefully for the reasons I'm explaining here. But that should make sense. If you did think otherwise, definitely select that answer and it'll give you the explanation as to why that would not be correct. So hopefully everybody's learned all this. You've completed 2 modules today, and we're well on our way now to completing the requirements for the Azure Data Fundamental certification. So again, I do want to drive here that while you're attending the Game of Learners data clinics, there is an ability to complete the Data Fundamental certification at your own leisure alongside this content, which is highly relevant since these are related concepts. And we're also giving you the ability to sit for that exam for free. So if you head to aka.ms/dataclinics/register, all of those available, all of the available content that's required to be completed, if you complete it, you'll be able to get a free voucher to sit for the AZ900 exam. That is for the first 200 attendees. So you'll want to register today and complete as soon as possible. The first 200 to register and complete get that free ability to sit for the Azure Data Fundamentals certification. And finally, if you have questions and you want to ask those in the chat at any point in time, you can head to aka.ms/dataclinics/forum, and you can also ask your questions after this presentation and get answers in a long-running forum that we're running throughout the Game of Learners series. So if there are any questions, it's been a pleasure for us presenting with you today. We're going to go ahead and bring Josh back online to hopefully get his views from what has been going on in the chat today, understand how folks seem to be learning. And we'll also go ahead and put up our slide for those upcoming GOL sessions as we talk about that in review. So Josh, how's things going in the chat?
We have one question which someone asked. Let me see whether I can get that. This question came right immediately after the first module, and someone asked whether it was possible to create an index on less than the value.
So yes, you could totally create an index on any field or column based on the data type of that. You would say it would chop it up, and I get what Kajex Klaus is trying to say here. Like, can I look at, say, the price and maybe slide that into buckets where it's like things that are less than this one, things that are less. The thing is, the query optimizer, depending on the data type, will figure out the best way to partition that data into buckets. So you can totally do that. There may even be ways to tell the query optimizer how you want to do that. But ultimately, what you would do is, if you had a numeric value in the column, create the index there and let the query optimizer do the work for you. It will figure out the best way to zero in on that data. That's a really great question, and definitely shows that you're understanding that concept of indexes and how that can help you. So yeah, hopefully the chats are lively. That's a great question. Inimaset Uma is asking about how to configure the sandbox. So in certain modules on Microsoft Learn, there will be an Activate Sandbox link that will sort of walk you through that. In fact, we could probably bring up a link to that content. Josh, if you want to maybe pop into the chat, I think we have the Microsoft Learn Sandbox documentation that will show you how to create those. What's really awesome about them is when you do have a sandbox created, you can easily jump in to Microsoft Azure without the need for a subscription. So you can free, without any cost, deploy things into the Azure portal without needing to set up a subscription. So this is a really cool functional feature. We'll go ahead and bring that up here. Questions about the sandboxes. This will give you a bit more documentation on that. We'll hopefully, Josh can relay this link into the YouTube channel chat.
Yep.
Perfect. So I guess the last thing we'll say here as we're nearing the end of time is join us for the remaining sessions. So Josh and I will be here again for it. Great question, by the way. Inimaset is asking, is this for AZ900 or DP900? The voucher would be for DP900. That is the Azure Data Fundamentals exam. So be sure to join us for our upcoming sessions. Josh and I will be back here on Thursday. We'll be going through the deployment and configuration of servers and databases for Azure SQL. Things are going to get a little bit more hands-on during this lab, so definitely come back for that. If you are having errors, definitely join us in our forum. We'll be there answering questions after the fact. If you can provide screenshots, we're happy to help. But the big thing we want everyone to look forward to is please join us as we continue with these GoL data clinics throughout the month of November. We hope that you can learn everything there is to know about Azure Data Services and are excited about learning and sharing with you. It's been a pleasure presenting with you today. Josh and I had a great time working with all you, and look forward to the next session.
Thank you.
Thank you, everyone.